I am showing voltage neutral to equipment ground at this receptacle. How is that possible if at the main service, equipment grounds and neutrals are bonded together? Same with this ability to generate sparks neutral to ground. It's just Ohm's law and voltage drop. I'm going to draw it all out and explain it so it makes sense, but I want to show you one more demonstration that proves the point. All right, this is a very big do not try this at home moment. You see this 14 gauge wire? It's connected to the red leg for my main service disconnect. And it goes around here on the ground. It's zigzagging across the ground, and it comes all the way out here, past my pool, and into that window on my shop. That's my shop on the back side of the pool house. So pay attention to that window. This is that window. That 14 gauge wire comes straight through, and the other end of that 14 gauge wire is right here. So this receptacle and all of these loads are being fed off the red leg, and this is bonded to the red leg at the main service disconnect. So we know they're bonded at the main service, but out here I get a 4.6 volt difference from hot to hot of the red leg. Also, if I do this very foolish, irresponsible thing of connecting that hot wire straight to a yoke of a receptacle, a jumper from the hot to the yoke will make sparks. All right, let me explain all this. Everyone knows that if the extension cord is too long and the load is too big at the other end, you lose voltage. You get voltage drop across the extension cord. And the Ohm's law behind that problem with the extension cord is series circuits. If you put loads in series, they divide the voltage between the loads in proportion to the resistance of the load. The higher the resistance of the load, the more voltage you lose across that load. So here's a circuit, 120 volt circuit. There's the load. You will read 120 volts being used up by the load. And this is how people think of it. And people know in the main service disconnect that happens, so how is there a potential difference between the neutral and ground? The issue is, real wires are not lines on a board. Real wires have resistance. So technically, each conductor is another load in series with the primary load. And on circuits that are not very long, it doesn't matter. But as they get longer, this resistance gets higher. If your numbers worked out perfectly evenly, so that you had 1 ohm resistance in this conductor, and 1 ohm resistance in that conductor, and 4 ohm resistance at the load, and you could get your meter leads to be long enough, those are the voltages you would see. They've been broken up in proportion to their resistance. The problem is you're not going to have a meter lead that long. That could be 200 feet. What happens is the equipment grounding conductor that has no load functions as an extension of your meter lead back to the beginning of the neutral. So if you wanted to know the voltage drop across your neutral, across your load, and across your hot, you'd have to take another wire and run it back to the beginning of the hot. Like I did out the window, and I've set up 3 meters to show exactly that in real life for part 2.